Hi everyone, my name is Tomasz Jaskula and today we'll be exploring temporality in domain modeling. I'm co-author of Strategic Monoliths and Microservices book and also an instructor for workshops with Kalele and Vogn's company. So this is mostly about me. Why temporality is so important? Temporality is a highly rooted concept in business software, but using just dates as basic data types is not enough to speak about temporality, because business software is driven and all business decisions are driven based on the temporality. And that's why we have tools like data analytics and tools that are crunching data and trying to conceptualize what data means are so useful for decision makers in companies. And yet in software design, temporality is often overlooked. And it's overlooked because it seems obvious that if we just use some date types in different parts of the software design and system, it's enough to have this concept of temporality. So unfortunately, it's not the case. And let's start with a simple use case. So in this talk, we will talk about dates. There will be around 5 different dates to keep in mind. So if you are one of those people that struggles to remember your wedding anniversary, you might have some issues to follow up. And so let's say we have an example. May 2nd, we have an order for 500 kilos of alloys. This is a purchase order for aerospace company, and we are purchasing alloys from different suppliers. So next, 3rd May, we have an initial expected shipping date that were communicated for May 10th by the supplier. And this is what Carola said, it's part of these negotiated domains where we have to agree on certain dates because it's very important in this kind of domains. And next, 8th May, the expected shipping date was delayed to May 17th, for example, by the supplier. And finally, the order was cancelled for different reasons. So let's just think of it how it could be modeled basically in a software. And most of the time we are using dates, but the dates are not tracked. They are just simple information, and we are building on top of it a special application logic to deal with them. And if the dates are not tracked, any request to the software system would yield the latest state, and that's all. Because all the changes in between are lost. They are simply overwritten. And business people can already answer different questions. For example, how many kilograms of alloys were ordered in May, which purchaser achieved the highest discount in May, what supplier had the biggest delay between the order and shipping dates. But is it enough? Not being able to track changes over time, it results in missed business opportunities. For example, purchasing department might work to consolidate orders of some alloys to achieve better discounts, or some suppliers might need to be deemed unreliable because they are delaying all the time before shipping orders. And keeping just the latest state doesn't allow to answer this kind of questions. Of course, business people have tools like data analytics, and they can answer these questions, but this doesn't give an immediate feedback. And if we had the following business concerns, this kind of questions could be of great value. So, which supplier takes the longest time to provide the shipping date? Which purchaser changes the quantity the most often? Which supplier offers the highest discount than initially negotiated? This kind of question, if we have the temporality baked in our software, we can build business rules on top of it. And what does it mean? Is we can have, many people would say we have historical tables that just track different changes, but it's not enough. Historical table is just an ad hoc history, and what I'm talking about here is to have temporality baked in that persistence, for example, storage, cares off automatically. So in the example here, we just have different temporal changes that were tracked. The first line is we just open the order, then the next two lines, the delay shipping date, the shipping date was delayed, and finally the last line, the order was cancelled. So without the tracking, we would only see the last state that was calculated and the order was cancelled. So the history of slipped expected dates and would be completely lost. Business activities that were counting on availability of the supplies, like for example cutting alloys, picking other items for shipping, and communication with the end customers, may have been impacted by the lack of the information. So temporality enables the following usage scenarios: auditing, time analysis, time travel, anomaly detection, and that's very useful for many business cases. And now we know what the temporality is about. Let's talk about bi-temporality, so which is a special case for temporality. And we have different temporalities. We have different time axes. For when we have one dimension of time, we just have one time axis, which is the transaction time most of the time. Bi-temporal, we have two time axes for validity time and transaction time. And tritemporality, where we have validity time, transaction time, and decision time. So given that, we just can go forward. We can say that there may be a use case like tracking purchase performances, and each individual purchaser's performance can be evaluated based on how much discount they can get from the supplier. So when you are buying alloys in aerospace, it's very expensive, and getting a discount is very important to have a lower price. And if this information is tracked through orders life cycle, it would be useful for business. They may come up with something like that. On April 25, we learned that John negotiated 6% on April 10th. This is the implication of bi-temporality. So for example, what you could see, you have this special row highlighted in gray, which has two time axes. The first one, transaction date, because on April 25th, we've learned something. We just recorded this information to our systems. and we know that it should have been true on 10th April. So we set on the next on the validity date X the date for 10 April. So our temporal system should be able to not only treat this information as simple information that we need to put the application logic on to understand what's happening, but it should order accordingly to what really happened in the system. And because why it's important? Maybe there is another use case that 28th of each month there is a purchase performances that are evaluated of all shipped orders for the period of time, for example, for 1st to 21. And that's maybe a bit complicated, but what you have to see is that because you have those two time axes, the transaction one is just records what happens in a system by the time it's recorded into it, and the validity time, often called as well application time, it's a time ax that is set by the user because he knows where this information should be valid from on which date. And we could say, okay, we have already dates. We have different type of dates in our domain model. How it's different, just to say that we have different axes. Because based on that, our software, when we are updating data, should be able automatically to version information, and we could be able to request different information based on those two axes, the time axis. Okay, so what we can see here is that if our performance evaluation process runs on 28th of April and it has the vision from the 1st to 21st of April, and if we look only on the transaction time, we wouldn't see the discount of 6%, which happened on 25th of April. And that's why the transaction time allows to answer what did we know on the 21st of April. We knew that there was no discount at that time because we didn't look at the right time axis. But if we have the information that we take into account, the validity time axis, we take this into account and we can answer the question, what should we have known on the 21st of April? So even if we run our performance evaluation process on the 28th of April and we say you have to look at what should we have known on the 21st, it will say, okay, there was a discount of 6% that we should take into account into the calculation of our process. And this open new use cases like retrospective and trend data analysis, forensic discovery, or data auditing. So, because we said bi-temporality is a special case of temporality, we still are getting the same features from temporality, but we also add some new features like retrospective and trend data analytics and forensic discovery. So that's the new features that are enabled when you are relying on bi-temporality in your software. And yeah, so the question is, bi-temporality where we should use it. And we should use it when we need to take into account retroactive changes. And they have to be taken in account in a history. So retroactive changes can also be an issue when you are taking care about actions that are based on past state. If we change state retroactively, we need to consider what should have been done but wasn't, and there are different use cases that I will talk shortly right after. And as I said, temporality is important. So basically, when you are using RDBMs, there is something called temporal tables, and it's specified by SQL 2011, but it's partially. It just takes care about this transaction axis, which versions for you data automatically, and you can query with the transaction dates, but it doesn't take into account the validity axis. And you have different implementation from third-party vendors that do that. You can use software who has features for bi-temporality, but it depends really on your domain, what you need, and what should you implement. And that's why, for example, this SQL 2011, it's just the transaction axis most of the time. But there are other times to deal with temporal design in a model. And most of the time, bi-temporality, we speak in the context of event sourcing. And event sourcing, Greg Young said, that's quite nice. State transition are an important part of our problem space and should be modeled within our domain. And I would say as well that time is so important for business that we have to model it explicitly. And temporal modeling means that we use time-based artifacts as first modeling systems. And for event sourcing, we are using domain events. Domain events are very good artifacts to represent time and what happens at what point in time. And event is just an immutable fact. So there is a verb, and in the past tense, something has happened. It's a fact, and we can ignore it, but we cannot deny it happened. And we capture the series of different domain events, and if we are using event sourcing, it will be part of the event stream that will be the state that will serve for calculating the state of our aggregate and application in a broad sense. So let's say we have different events for the same use case. We could say we have ordered, shipping date estimated, discount granted, and shipped. And we can just represent the same approach we've used with temporal tables, but with event sourcing. And this is exactly the same design using different temporal artifacts. And just to say how we are persisting this state. So when events happen, we just store them one by one in a stream and in an event store. And at some point at time, we could have an error, so we cannot delete from the stream for event store. We have to compensate with another event. And why? Because there is no delete, it just append only store, and that's very important because it's just, you cannot falsify the history. And this case for compensation with events and deleting history is kind of interesting because language matters. And we could say we have this discount granted event that needs compensation. How we do that? And we can design this. We can say, okay, so we use another discount granted with different value event, and it will, in a sense, when you will replay all the events from the event store, it will just override the value that was firstly defined by the event before. But you could also say, I have a specific event for that, like discount adjusted. So in the first place, in the first case, there is a lacking knowledge when that adjustment is made. Is it, we have to derive the knowledge from the context, because it could mean that we set up the discount for the first time, or we are negotiating, or we are making errors, or we could just have explicit knowledge for a use case, and we can design events in that way. So the issue is that not because you have events that you will have all the knowledge that is explicit in every case. You have to all the time do the explicit design, and to go there for example, reading the state, you have just to see that if you are taking the transaction time into account, we will be replaying events as they are recorded into the system. And if we are taking into account the validity date, we have to reorder them in order to be sorted by the validity. But again, this is for event stored that I know, that I am aware. It's not something that can happen on the event store level. You have to deal this on the application level, and it adds complexity. So, of course, event sourcing opens up new possibilities, because we have immutable data, we cannot falsify it, and we have done the modelization with time-based artifacts with domain events, which is very useful. And for just to end quickly, like I said, bi-temporality is very useful when you have retroactive changes and actions, and you have different patterns that you may be aware of. So, for example, retroactive backdating or forward dating. So when user is setting the date in the past or in the future, we can have patching or forward patching, saying we change dates because some mistakes were done, or cancellation. It has a special meaning in a domain, or scheduling. I won't go into details, but just you can contact me on Twitter, and I can share with you some of the information. But there are also retroactive paradoxes. So you can have stream history inconsistencies, causality violations, because let's say you have a simple example of a grandfather and a son and a grandson. If a grandson goes to the past and kills his grandfather, does it means that it should never have existed? So that's why you can have this kind of inconsistencies, casual loops. There's other examples, but you can deal with it in different ways, like parallel universe, self-consistency, creative avoidance, and, for example, self-consistency principle, which was developed by Igor Navikov to solve the problem on time travel paradoxes. Yeah, for example, it postulates that actions which would lead to paradoxes simply cannot be executed. So that's kind of thing you can model in your domain model. It's similar to the laws of physics, which restrain or influence on the real world. And yeah, and a creative, another way is self-consistency. Sometimes it's depicted as a restriction of your free will, that someone just cannot act in a certain way. And for example, creative avoidance, if we go back to the example of a grandfather and a grandson going to the past, we could say that if that happens, so maybe it could happen because in fact his grandfather is not his biological grandfather, so there are many ways on going and working around the problem. And yeah, so this is like temporality takeaway. We are contextualizing time changes. We have this auditing, time travel analysis, anomaly detection, retrospective and trend data analytics. And this is all baked into the domain model, and user can have rules that act directly on the application state and not needing, data analytics and all that tools are still needed, but data analytics tools are often, they give context to the data a posteriori, which is not so great in many situations. So, thank you.
So from experience, I can tell that bi-temporal or even n-temporal problems, they can make your mind melt. So it's really good to have a proper modeling approach and proper ways of dealing with
I
that.
think that the best way to start is to just remember the wedding anniversary of your husband or wife, and that would be a very good start.
Okay, thanks again, Tomasz.
Yeah.